Hi students, today I am discussing work power energy. In this work energy power, I will discuss the numericals on work done in this case. Numericals on work done by the variable force. So in this case, the first problem I am taking here. See what is given in the question. I will read the question once we can see. A force of F vector is equal to 2xi cap plus 2j cap plus 3z square k cap newtons is acting. So force is given. This force is acting on a particle. This force is acting on a particle. So find the work done means we need to find out the work done by the force in displacing the body from points are given 1 comma 2 comma 3 meter to 3 comma 6 comma 1 meter. So this is the given data in the problem. In this problem, first I will take what is the given data. Given data, once we can see here, F vector is equal to force vector is equal to 2x into I cap plus 2j into 2j cap plus 3z square k cap. Newtons is given. Similarly, some points are given. Those points are 1 comma 2 comma 3. Second point is given 3 comma 6 comma 1 is given. See, this is the 3 points are given means in this case this particle is acting in 3 dimensions. And again if you observe the force, I cap, j cap, k cap is given means 3 dimension only it is given. That's why I will take this 1 comma 2 comma 3 is nothing but in here x1 comma y1 comma z1. Similarly, the second point is given 3 comma 6 comma 1 means here x2 y2 and z2. So this is given data. We need to find out in this case work done. Then how to find this work done? If you give this type of the numericals means in this case, see, already you know about this one. Work done formula is W is equal to F vector dot dx vector. Here I'm going to discussing one more point. So what is that point means in this case? What is the difference between the work done by the variable force and work done by the constant force? So in the constant force, there is no function, but here it is a function in this case. Now we can see this is the 2x 2 and 3z square. This all the force is given in terms of the function, in terms of x is given. That's why if you take constant force, they won't give like a x value, z square value. That's like that they won't give. They should give only 2 I cap plus 2 j cap plus 3 k cap. That's like that only they will give. Now w is equal to f vector dot dx vector. F vector is nothing but in this case 3 dimension, right? That's why fxi cap plus fyj cap plus fz k cap. Similarly, if you take dx vector, that is dx into I cap plus dy into j cap plus dz into k cap. These two values you please take in this case. Then w is equal to here f vector is nothing but fx into I cap plus fy into j cap plus fz into k cap. So dot product. Now dx value we can take dx into I cap plus dy into j cap plus dz into k cap. Right. Now we can see here, this is fx into I cap. This is also dx into I cap. I cap means same type of quantities we can take, because I cap dot I cap value is 1. That's why fx dx plus fy dy plus fz dz in this case. Okay. So but this is the work done, right? This is the work done by the variable force, means we have to take the formula is integration here. So that is the integration. Here also integration. So here also it is coming integration in this case. So here fx means in this case x coordinate. So x coordinate is given in the question is 2x. Fy is nothing but y in the direction is given in this case 2. And fz means in this case is given 3z square in this case. So finally fx place I will take in this case integration of, so 2x dx plus integration of 2 into dy plus 3z square integration into dz. If you take this is the limits from x-axis x1 to x2, similarly y1 into y2, y3 into z1 into z2. Okay, that is equal to, now if you see 2 is the constant. So next, what is the integration? This is integration of x dx. Integration of x means what happen? X square by 2. Limits are in this case. X1 is, this is the x1 means 1, and this one. X2 means 3. So 3 plus 2 into. So integration of dy means y. Limits are y1 and y2 is nothing but here 2 and 6. Limits are 2 and 6 plus 3 into z cube by 3. Similarly, if you take the units are z1, z2 means 3 comma 1, 3 comma 1. So that is equal to 2. Here 2 to get cancelled, here 3 get cancelled. Then what is the remaining x square? In the place of x, we can take upper limit is 3, then 3 square is nothing but 9 minus 1 plus 2 into upper limit in the place of 6 minus 2 plus, so z square means 1 minus 9 in this case. Sorry, this is a 3 cube means 27. That is equal to 9 minus 1 is nothing but 8. So 2 into 4 is nothing but 8, and minus this is the 26. So that is equal to 8 plus 8 is equal to 16. 16 minus 26 is nothing but minus 16. 16 is 10, minus 10 joules in this case. Work done is equal to, we got it in this case, W is equal to minus 10 joules in this case. Minus 10 joules. Second question. See, an object has a displacement from position R1 to position R2 under a force F is given. So we need to find out the work done in this case. So here what is given? Force F vector is equal to, same function is given. That's why 3x square I cap, this is the variable force, plus 2y into j cap. Next one, R1 position vector R1 is given. R1 is equal to 2 into I cap plus 3 into j cap. Similarly, R2 is equal to 4 I cap plus 6 into j cap. So what is the formula work done? Work done is equal to Same in this is the see how what is the two dimension or three dimension means we can observe properly. So this is the I cap is given, this is the j cap is given, nothing but two dimensional it is given. So the formula is integration of f of x dx, directly I'm taking, plus integration of y axis j cap also is given, that's why f of y into dy. Limits also is x1 to x2, this is the y1 to y2. Take that, that is equal to integration of x1 means in this case this is x1. 2 is given. x2 is nothing but 4 is given. That's why 2 to 4. F of x value is here 3x square. 3x square dx plus integration of y value is the 3 comma 6. Then 3 and 6. So f of y value is here 2y. 2y into dy. That is equal to 3 is the constant. X square means x cube by 3. Limits it will come in this case upper limit minus lower limit. 2 2 comma 4. This 3 cancel here. Plus 2 is the constant. If you take integration for y means y square by 2. Limits are 2 to 6. Again 2 to get cancelled. So what is the remaining in this case? Work done is equal to, so x cube is the remaining in this question, in this part. X cube is nothing but we can take upper limit 4 cube. 4 4 just 16, 16 4 just 64. 64 minus again 2 cube is nothing but here 8. Next plus y square means like a 6 square is a 36 minus 4, that is equal to 64 by it is nothing but 56 and plus 36 minus 4 is nothing 1 minute. Here I think I took the wrong, this is the 3, we have to see this is the 3, this is the 3 here. So 3 square is nothing but 9. So 36 minus 9 is nothing but here 27. So 56 plus 27 is equal to here 83. So we can check the answer. What is the answer in this case? Third option is the answer. So now coming to the next question number 3. This is another type of the question. A force F is given 2 plus x. Again the function is given F is equal to 2 plus x newtons. So acts on the particle in x direction, where x is equal to in meters, nothing but distance is given. The work done by this force during the displacement of x is equal to 1 to x is equal to. So F is equal to here 2 plus x is given newtons. X1 is equal to something, x1 is equal to 0.1, 2, x is equal to 2. Direct formula I will take in this case. Work done is equal to integration, because only one dimension is given, x-axis, no, that's why only one dimension is given. I will take this is the 2 plus x into dx, only one dimension is given. Limits are in this case x1 to x2. Now we can, this is the 2 plus x is given, right? So we have to multiply this dx is inside this bracket. So that is equal to here x1 to x2, 2 into dx plus integration of x1 to x2, x into dx, that is equal to work done here. Now 2 is the constant. Integration of dx is nothing but here x. So I will get the value here. Points are given, see what, 1 comma 2, then 1 2 plus integration of x means here x square by 2. Limits again similarly same, 1 to 2, that is equal to 2 into, if you take upper limit is the 2, lower limit is the 1 minus 1 plus 1 by 2 is the constant. Then x square means 2 square. Upper limit is 2 square is the 4. Minus lower limit is the 1 square means 1 only. That is equal to 2 plus 3 by 2. I think it is the 7 divided by 2. So work done is equal to 3.5 joules here. Finally, I got it. Work done is equal to 3.5 joules. So this one, 3.5 joules. Next question. Next question also we have to see the question number, I think 5. A body is displaced from 0, comma 0 to 1 meter, comma 1 meter along the path x is equal to y by a force F is equal to x square j cap plus y into I cap is. Values are given in this case. We can see this is a two dimension, one dimension and two dimension. That's why x1 comma y1 is equal to here 0 comma 0 in the above question, in the question. Next, similarly x2 comma y2 is equal to 1 comma 1. Clear. Same, I will take work formula. W is equal to integration of x1 to x2. So x square j cap plus, sorry, x square integration of, in this case dx it will come, I think x square into, so okay, f for x into dx, no. So okay, this is the y into, in this case I cap, into here dy into I cap. So, and here also dx into j cap. But here we can see in the question is given x is equal to y. Now this is j cap I will considering, and this is the I cap I am considering in this case. So x is equal to y is given, but this values if you observe, this is x square, but this is the j. So, and this is also I cap. This is also y I cap, and this is the j. So this is not suitable. This is not good. But what to do means we have to change, because x is given, y means in the place of x square I will take in this case y. That's why integration of x1 to x2. So in the place of x I will take y, means in this case y square into dy plus, here I will take integration of, in the place of y I will take x, then x into dx. This is, so limits are in this, sorry, this is the y1 and this is the y2, this is the x1 and this is the x2. That is equal to y square is nothing but what, y cube by 3 integration, limits are y values are 1 comma 0, both are the same in this case. So 0 comma 1 plus x square by 2 for integration of x, means again limits are same 0 to 1, that is equal to, so 1 by 3, then it will get it in this case 1 by 3. Here you will get 1 by 2, that is equal to, you will get it in this case 5 by 6 joule. Work done is equal to 5 by 6. So don't confuse in this case. In the place of x square, this is actually y1, sorry, this is also y1 and this is also y2, and this is the x1 into x2, because this is the I cap, this is also I cap. Little bit confusion, please be careful this question carefully. Otherwise see the same equation I will write here. If suppose small mistake is happening, I am rewriting this equation. The w is equal to integration of, actually what is given, first one is x square into j cap is given. J cap is nothing but what will come, dy into j cap. So this is the dy, means I will take y1 to y2 plus integration of y into I cap is given means so dx into I cap. Actually this is the correct method. Okay, so here in the question is given x is equal y means I will take in the place of x square I will take y. That's why integration of y1 to y2 then y square into dy j cap dot j cap value is 1 plus integration of this is the x1 to x2 because this is the I into I, so x axis. So here y is nothing but x, so x into dx. After that we have to do this one, these values, we'll get the answer. Okay, thank you. Next see the one more question is given in this case. Force is given here. Force F is equal to k x square is given. F is equal to here k into x square, and theta is given 60 degrees with the x-axis, and the work is displacing from is x1 to x2. Work done formula W is equal to integration of k into x square dx cos theta. Limits are in this case x1 to x2. But here the numbers not given, only the it is given in terms of like x1 x2. That is equal to, here k is the constant, integration of x square means x cube by 3, x cube by 3. So limits are x1 to x2. If we take this is the theta is given 60 degrees, cos 60 value is in this case 1 by 2. That is equal to k divided by 2. This 3 also I will take here, then 2 into 3. So upper limit is x to the power x2 power 3 minus x1 power cube in this case. Okay, right. That is equal to finally k divided by x2 cube minus x1 cube. So this is the final answer for this work done. Next question we can see in this case. A force is given on a 2 kg body. Okay, so force is given, I'm taking here F is equal to 3x square plus 2x minus 7 newtons is given. Mass also is given, 2 kg is given. So if you see this is x is equal to 0 to x is equal to 5. Then x is equal to 0 to x is equal to 5. Then we need to find out the work done. Same formula I will take. Work done is equal to, so integration, limits are 0 to 5. That I am taking. So 3x square plus 2x minus 7 is equal into dx or ds is equal, okay, dx. That is equal, we have to multiply, this is the addition of integration. Multiply dx this side. Integration of 3x square dx. Limits are 0 to 5 plus integration of 2x dx. Limits are 0 to 5 minus integration of 0 to 5 7 into dx. That is equal to 3 is the constant, x remaining is x square. Integration of x square is nothing but x cube by 3. Limits are 0 to 5 plus 2 is the constant. Integration of x means x square by 2. Limits are 0 to again 5 minus 7 into integration of dx is nothing but x. Limits are same, 0 to 5 only. 3 cancel, 2 cancel. So x cube is the remaining. If you take upper limit is the 3 cube is nothing but 125 minus 0. plus this is also 5 square is nothing but 25 minus 0 minus 7 into um, so 5 minus 0. Then the final is 125, 125 plus 25 is 150. 150 minus 35 is nothing but 115 joules work done. This is the final answer. Next. So next we can see here graph type of questions in this case. Numericals on the work done by variable force. Graphical methods we have to see. So here one graph is given. The graph is on the y-axis is given force, and on the x-axis it is given a distance. Nothing but the displacement is given. I discussed in the concept. So force into displacement. This is a multiplication. I said multiplication nothing but area. So nothing but work done. Work done formula already you know, work is equal to force into displacement. So the multiplication nothing but the force into displacement area gives the work done in this case. Area gives the work done. If you observe the question is asking from x is equal to 0 to x is equal to 14 meters. Nothing but from here to here we need to find out the area we need to find out. If you observe very clearly for this diagram, this is act like a first one is act like a triangle, and the second one if you observe this is act like a rectangle, and again the third one is act like a again the rectangle in this a triangle in this case. So I will take work done is equal to first to area under fs curve or graph. First one I will take area for the first two part I will take plus second part I will take plus third part I will take. First part is like a triangle. Triangle formula is half into base into height. So 1 by 2 into base is 0 to 6 is nothing but 6 only, into height. Height is nothing but from we can observe here 0 to here the height will be 4, then into here 4 it will plus the second time you can see this is the like a rectangular shape. So length into breadth. Length is how much is 6 to here 10. 6 to 10 is the 4 into breadth no. So height is how much in this case. This is the again 4 plus last one is again triangle. This is the third one is also triangle in this case. Again 1 by 2 into base is from the 10 to 14 is the 4, and height is again 4 only. We can do the calculation. 2 ones are 2 twos are, then 6 into 2 is equal to 12 plus 4 into 4 is equal to 16. Again 2 ones are 2 ones are cancelled, then it is the 8 in this case. We can use 12 plus 8 is equal to 20. 20 plus 16 is equal to here 36 joules we will get. So work done is equal to, in this case we will get here uh, 36 joule. This is the answer for this. Okay, right. Next question also we can see. A force is acting on an object varies with the distance x shown here. The work done by the force in the moving object x is equal to 0 to x is equal to 6 meters. I think, sorry, I think I didn't copy that diagram in this case. I think maybe it is not possible to explain this question. So can you please leave this question. Come to the last question here. Force F on a particle moving in a straight line varies with the distance as d as shown in the figure. The work done on the particle during its displacement of 12 meters. So we can observe, be careful in here. This is the starting of this dotted lines, don't take it. Okay. So this is the graph actually. This is the graph. Shape of the graph will be this one. Exactly we have to see. Don't take the dotted line. Dotted lines is identifying the only the shape of the graph there. We need to find out from the 0 to 12. Again the same format. W is equal to formula for force into this area under fs graph. First one we have to observe this is like a rectangle, this is like a triangle. So this difference how much is given? 4 3 7 7 minus 3 is equal to 4 into this height will be 2. So plus uh, triangle 1 by 2, triangle here what, 1 by 2 into base is 12 minus 7 is equal to 5 into height is again 2, only 2 2 get cancelled, then 4 into is equal to 8 plus 5, that is equal to here 13 joules of work done. That's it. This is the answer for this last question. Okay, these are the some examples and some numericals based on the work done by the variable force without graphical method and graphical method. uh, I think previous this question I think I didn't draw the diagram, so sorry for that. And previous one more diagram there is small mistake is happened, that integration of x is equal to y wala. Can you please be careful those two questions? Okay, fine. So these are the work done by the constant and variable concepts till now. So next topic, I will discuss the applications of work done one by one. I will take the classes. Okay. Thank you. Thank you so much for everyone.